Right, for this next lesson, we are going to talk about logarithms, natural logarithms, and e. So for this first part, we see that an expression in the form y equals a raised to the x power will graph an exponential. So, and again, pay attention to where your x value is. With x being in the exponent, that is what's making this an exponential. So pay very close attention to this form here, because that will change things for us. And notice that it says as an exponential graph tends to explode based on the value of x, since x is that exponent. So notice also with the graph here that we have all kinds of different ways or different numbers that we can have our base, but that base here, notice each one of them, it's going to generate a very similar graph. So as far as our base, especially the 2 and the 3, notice they're very similar. Now, it goes on to tell us that we have a graph of y equals 1 to the x power. Now, keep in mind, if we graph y equals 1 to the x, no matter what power we put there, we're going to get a value of 1. So that's really going to graph a horizontal line. So that's going to be our horizontal line, y equals 1. So really, our base has to be something other than 1. Also, it goes on to tell us that if a is less than 0, sometimes we won't get an answer back. For instance, if we had -2 raised to the 1/2 power, well, -2 to the 1/2 power, that's really talking about the square root of -2. So that's really not going to generate much for us. And so we have to be careful what we let our base value be. So that's talking about, again, the 2 that we see above here, the 3, and the 0.5. And it goes on to talk about we can have an exponential growth, and then we can also have an exponential decay, and that all depends on the value of a. So no matter what, exponential curves of the form y equals a raised to the x power, they do have certain features. There are some things that do not change. One of those things would be a point that they would have in common. If you look at the graphs, notice that the graphs all have this particular point in common. And even over here, when our base is between 0 and 1, that point is still in common. So let's say that the point it looks like they would always have in common would be the point 0, 1. Now, as far as the domain, that's talking about how far left to how far right our graphs go. And notice no matter what our base was, our domain was from -infinity to +infinity. And then our range, well, that's how far below the y-axis to how far above the y-axis. And notice we don't have any negatives. So here it's going to be from 0 to +infinity. So there's some major characteristics that we have for our graphs of exponentials. Now, something else that it's telling us here is when we're solving basic exponential equations, we have to use this fact here that if I have two base values that are the same, and if they're equal, then notice the exponents must be equal. And that's what we're going to focus on first with this, and then we'll extend that concept onto something else. Okay, looking at our first examples, we do need to work these out and solve for x. Now the problem here is that our x value is in the exponent. So we're going to have to change some things around. Now 2 is the most basic base that we have. 2, 3, 5, try to go for those numbers. And so I need to change 8. We need to change the appearance, not the value. I know 2 to the third is still 8, so I didn't change the value. I just changed what it looked like. And notice 2 to the x plus 1 will stay the same. Now that I have these bases are the same, then I can set up an equation from this. And I'm going to set my exponents equal to each other. So I would get x plus 1 equals 3. And so very quickly we see that x would have to be 2. Okay, same idea for number 2. Again, we would have to get our bases to be the same. And notice I can rewrite 9 to be 3 to the second power. And again, I'm not changing the value of 9. I'm just changing what it looks like. And again, notice now that we have our bases the same, we would set those exponents equal to each other. And we would solve. And so we have 2x equals 5. Divide both sides by 2. So notice that x is going to be 5 over 2. Okay, continuing on to the next. And again, same process. We still try to find 125 to what power? Well, let's see, 5, we would bring this down, 1/2 x plus 4, and 125 would be 5 to the third. And so again, we're ready to set up our equation. 1/2 x plus 4 equals 3. We would subtract that 4 over and then multiply by 2, so x is -2. All right, now this one's a little bit different. We have 3 to the 4x minus 1, but then we have that 1/3. So we're really not needing to change it to be 3 really to something that's not hidden there. We need the reciprocal. So we need to flip over that 3, and that exponent of -1 is what we need to do that. And now I have the bases are the same. And so we are going to go through and solve. And let's see, that's going to be 0, isn't it? Oh, me. So we have x to be 0. So there's the x value we're looking for this one. Now, let's see. Now let's incorporate that with number 5. Again, number 5, very similar. So as we go through here, we still have 7. We're going to bring that down. 3x plus 1 equals, now 49, we need to flip this over. And so then we need to change that to be 7 to some power, which I know that is 7 squared. So really, I'm going to change that inside 7 to the -2. And then that's raised to 1 minus x. And now we have an exponent raised to an exponent. We need to remember to multiply those two. So now we're ready to set our exponents equal to each other. I have 3x plus 1 equals, and we can go ahead and do our distributive property here. We can do some of these steps in our heads. It's quite okay. That would be -2 plus 2x. We need to get our x's together on one side, so I'm going to subtract my 2x over. And so that's going to give me x plus 1 equals -2. And then I would subtract my 1 over. And so it looks like x is going to be -3. So that would be my final answer there. All right, now number 6 is a little bit different because now we're going to have to change both sides. Notice that 27 and 9 are really 3 to some power. They're just in disguise. So 9, we know that is 3 to the second power, and that's going to be raised to the 2x minus 4 equals 27 is 3 to the third. And then that will be times x minus 1. Now, a common question here, well, how did we know to go to 3? Because that is the smallest base that these two have in common. That's how we know. Now that we have those bases, we can set up our equations. And I'm going to go ahead and do our distributive property. So we have 4x minus 8 equals 3x minus 3. And again, if you go through all the solving, we would subtract 3x over and then add 8. So it looks like x is 5. Okay, moving on to the next one. And again, 4 and 32, you want to try to keep the base as small as possible. So yes, we would change 4 to be 2 to the second power, and that's still going to be times 5x minus 1 equals, well, 32, that's 2 to the 5th, but then it's going to have to be raised to the 1/3 power to take care of that radical. And now we can go ahead, we have our bases the same, so we're going to have 10x minus 2 equals, and remember that's the same thing as 5 over 1 times 1 over 3. So that's going to give me 5 over 3. If you don't want to work with that fraction, then you can multiply everything through by 3. And I'll go through that just this time to see, because some people hate working with the fractions, and we can get rid of the fractions this way. We would have 30x minus 6 equals 5. And let's see, if we add our 6 over, we get 11. And then divide by 30. So x is equal to 11 over 30. Okay, moving on to this one. Now this looks really strange because we want that to be 1 on this side. So we're still going to have to do 8 to some power, and you have to ask yourselves, well, 8 to what power gives me 1? Well, 8 to the 0 power. So that tells me that 5 minus 2x has to be equal to 0. Negative 2x equals negative 5. Now be careful with your signs here. And so you're going to get 5 over 2. Okay, now here, whenever we are solving our logarithms, we have to keep in mind our exponents because it's very similar to the same thing as talking about exponents. And what this is saying here is 2, this is our base, and it's saying 2 to what power gives me 8? Well, 2 to what power is 8? Well, that what power is 3. So this entire logarithm is equal to 3. The same is true for the next one. Again, same idea. You're asking yourselves 3 to what power gives me 81, and that what power would be 4. Okay, the next one, 5 to what power is 1 over 25? And so here we're going to have to do very similar to what we did just a minute ago on the previous. We need to flip 25 over. So I know I need a negative 1 exponent. And then 5 to the second is 25. So that means x is going to have to be 2 times negative 1 or negative 2. Okay, and then our last one, and again, this is going to be very similar. We're going to say 4 to what power gives me 32. And again, we would have to change this to be 2 to the second power raised to the x equals 2 to the 5th, because 2 to the 5th is 32, and 2 squared is 4. And we have like bases now. So we just deal with our exponents. So that means 2x equals 5. So x is 5/2. And continuing with the same idea, now these problems are a little bit more difficult, so don't give up. So for this first part, again, we're saying 8 to what power is equal to the square root of 2. So let's do some rewriting. 8 is 2 to the 3rd power. That's going to be times x equals 2 to the 1/2 power means square root. And so now equal to 1/2. And now we would divide both sides by 3. Now that looks terrible on that side. Now keep in mind what you were doing. You were dividing by 3. So we really have x equals, that's going to be 1/2 divided by 3, which is really 1/2 times 1/3. So our final answer is going to be 1 over 6. Okay, moving on to the next problem. And again, we'll go through that same process. So again, this means 25 to some power equals 5 to the 1/3 power. So 25 is 5 to the second power, and we will multiply those exponents together, equals 5 to the 1/3 power. And now we're ready to set up our equation. And so we would have 2x equals 1/3, and we would divide both sides by 2 or multiply by a half since we have a fraction. And so x equals 1/6. Right? Continuing on, 36 to some power equals, now this one's going to be strange. We need to flip the square root of 6 over, and we know that the 1/2 power means square root, so that's really to the negative 1/2. And so 36 is really 6 to the second power raised to an x equals 6 to the negative 1/2. And so we can set up our equation 2x equals negative 1/2, and dividing both sides by 2 or multiplying by a half, either way you want to think about it. So x is negative 1/4. Number 16. Again, same idea. This means 9 to what power gives me 1, and hopefully y'all see that that has to be 0. Okay, continuing with our notes, here we're going to have 9 to some power gives me 0. Now, a lot of times people want to say, oh, x has to be 0, but 9 to the 0 power is 1. So really, there's no value we can plug in for x and say 9 to that power gets 0. So for this one, it does not exist. And very similar over here with number 18, same idea here. We're going to say, well, 3 to what power gives me negative 9? And the most common wrong answer, students will say 3 to the negative 2. But please remember, 3 to the negative 2 means 1/9, not negative 9. So here, this one does not exist either. Now, it would be tempting to continue this and say, oh, this does not exist on 19. But 19, we've got a couple of steps here we can do. Keep in mind, this does say 5 times what we get for this answer. So let's look at this answer first, and then we're going to say 5 times that. So 4 to what power gives me 8? And we're going to say, well, 4 is really 2 squared raised to the x. So we get 2x, and 8 is 2 to the third. So here we have 2x equals 3. And so x is going to be 3/2. But now that's what that entire logarithm simplified to. So we really need to come back to that 5 and say 5 times 3/2. And remember, that's the same thing as 5/1 times 3/2. So this is going to be 15/2. Okay, and number 20, very similar. Again, let's figure out what's here on the inside first. So let's see, that's going to be, and let's just write it, 9 to what power gives me 1/3. 9 is 3 squared, so it's 3 to the 2x, excuse my cat, equals 3 to the negative 1. And so here we're going to have 2x equals negative 1. So x is negative 1/2. But again, that's what is inside the parentheses, so we would need to square that. And so here we would have negative 1/2 all squared, which is going to give me 1/4. Okay, and we'll very quickly go through these. Not a lot of work here to be shown. You do remember that if the base is not specified, then it is assumed to be 10. So for 21, notice there's no base written, so you're going to be thinking 10 to what power gives me 100. so that what power has to be 2. The same is true for 22. Again, same idea. So 10 to what power gives me 1, and that what power has to be 0. And for 23, again, continuing on, 10 to what power gives me 1/10, and hopefully we see that is -1. And for 24, again, same idea, 10 to what power gives me, well, if we flip over that 1,000, I believe that's going to be 10 to the -3. So everything inside that parentheses reduces down to be -3, but then we need to square it, and -3 squared is +9. Okay, continuing on with our pattern. So for 25, again, it's 5 times what we get here, so 5 times, and again, this is saying 10 to what power gives me the square root of 10, which is 10 to the 1/2. So hopefully we see that x would have to be 1/2, and then 5 times 1/2 would be 5/2. Okay, moving on to the next problem. And so hopefully we see here we have 10 to some power equals 10 to the 1/3. So x would have to be 1/3, but then we had our -3 that we were multiplying here. So -3 times 1/3 is going to give you -1. Number 27. And 27 looks strange, and you might be tempted to multiply out 10 to the 4th, but don't. Because again, this question is saying 10 to what power equals 10 to the 4th. And so x equals 4. It's right there. And we could do the same here, 28. We could say, well, 10 to what power is 10 raised to the square root of 5. So that what power would have to be square root of 5. So hopefully this is a great review, and we've learned something from our logarithms.